time has lost all meaning in some sense. Like it's crazy to think that AMP is only 5 months old. It feels like 5 years old. And it's crazy to reflect on the fact that like coding agents as like a product category weren't really a thing until like mid to late spring of this year. Uh, but like they've changed the way that I code, and they've changed the way that everyone I know codes. All an agent is, stripped to its bare bones, it's basically like for loop plus a model and a set of tools that it can invoke to gather context or act on the world. Allow me to opine why I don't think that like pure scaling is going to lead us to like AGI nirvana. A couple hundred of like the Fortune 500s and government agencies, everyone ranging from like growth stage startups, like Stripe or OpenAI, or to like public companies like Uber is still a customer, Lyft, a bunch of the big banks, and various government agencies around the world.
Welcome to the first Hidden Layer podcast here in Hazy. How you doing?
Doing well. Great
So
to be here.
thank you very much. This is, do you want to introduce yourself? And
Hey everyone, I'm Beyang Liu. I'm the CTO and co-founder of a company called Sourcegraph. We build a code search engine, and we're also working on a new coding agent called AMP.
we met in what decade?
Was it 2011 when we met?
I think it was probably 2012 maybe. Then I think you were TAing iPhone applications. Is that what it was? CS 193p?
Yeah, during the mobile era.
When mobile was hot.
Yeah, it was so hot back then.
That was BC, before ChatGPT.
Yeah. Well before. During one of the AI winters, I think.
That's right. Yep. Back when these things called support vector machines existed.
Yeah. Guys even know what they are?
Yeah.
Talking to the studio audience.
Raise your hand if you guys know what a SVM is and studied it.
Oh, okay.
That's pretty good. That's pretty half the crowd here. Good. All right. Well, let's get into it. I think the first one is just, I find your guys' founding story so interesting. And also like the trajectory of the company. I'd love for you to just kind of like double click in. You and Quinn are at Palantir, which was like the the OpenAI of our era, which is the coolest place to be. Everyone wanted to work at Palantir in 2012, 2013.
Yeah.
And so like, tell me, founding the company, why, what was the thing you were going after, and how did it come together?
Yeah, so like my co-founder and I met. We're both engineers at Palantir. I think we're both drawn to the mission of the company, which was kind of distinctive at the time. Like a lot of the other startups you saw at the time were like very kind of like social, mobile, like in that vein. But we liked the mission that Palantir was pursuing, and we signed up. There were a lot of other smart people going there at the time, and um, I think what we both realized in working at Palantir, like we're both developers by background, so we both love to code. Like building software is like a really fun thing, and I think what we realized very soon after, it was like Palantir was both our first jobs out of school. What we realized very soon after joining, there's nothing against Palantir, but just like the life of a professional software engineer, even at like a fast moving startup, like 99% of it is what you might call toil. It's like reading through existing code someone else wrote, maybe they're no longer at the company, trying to make sense of what's going on in it. Palantir specifically, or like dumpster diving into these like large enterprise code bases, because those were our customers. And 99% of our time was spent not actually like applying our forebrains to some sort of like creative problem solving task, but to these very like neuromechanical tasks, like understanding this existing code, finding like a shared library that we're supposed to use, figuring out how to use it. And so the motivation for Sourcegraph originally was just to take the drudgery out of professional software development by making essentially like taming like big code bases and making them easier to grok, easy to understand, easy to work with.
And then like, tell me about the beginning. Cause like, no one's at a public company is going to trust you with all of their code, and you're like two guys in Palo Alto in a garage. So like, how does Cody come about? How do you know you had product market fit? Like, how long did it take to get to PMF?
Yeah, so it took us like a number of years to actually find what I would call like true product market fit. We had the Palantir background, which was useful for like some introductions. We knew like engineering leadership at some, larger companies, some like growth stage startups and that sort of thing. But a lot of it was just, trying to build a product and anticipating what we thought people would want, what we ourselves wanted. But um, I think one of the early challenges with building Sourcegraph is that this notion of like code search, I think still to this day is not like it's not like a standard tool. It's not like, everyone knows they need an editor of some sort. Everyone knows they need like a terminal of some sort to write code. But not everyone realizes they need code search. It's one of those things where like you talk to people who've used a code search engine, like a legit one, either like built in-house by some random person at their previous job, or they used one of the ones that are used in like open source communities, and it's like they can't live without it. They never want to like code without it again. But then you talk to the people who have never used it before, and they're just kind of like, why do I need this? And so a lot of our earlier years, I think, was actually spent trying to sell not just Sourcegraph specifically, but the whole like product category to a lot of people who didn't quite get it.
Mhm. And who was the first customer that was meaningful, that like really took a chance on you guys? And
So there were actually two first customers in Sourcegraph's history. I say two. One came before the other. The first one was actually Twitter. This was like Twitter circa, I want to say like 2015 or so. And that was an awesome deal to get. It was like this ex-Google person who'd used Google's internal code search engine, which I think anyone who's ever like worked inside of Google will know about code search. And he left Google and really missed that tool, and he wanted something similar to use at Twitter. But then what happened was we had them as our sole customer for a while, and then like a year and a half or 2 years later, they like churned, and then we went from like 0 to 1 back to 0 again. And then we had to kind of like wander in the desert for a little bit more. And then the second first customer was Uber, and so that was kind of like a restart. And it was like a very different product that they ended up adopting. It had evolved and improved a lot. And then we got them, and then after that, things started to kind of like grow of their own volition.
yeah, I mean, that's kind of the trend. I was saying with Focal as well. A big first customer churns, but
Oh, that happened to you too?
for sure.
Oh man.
And yeah, it was Walmart, and we have like the biggest retailer in the world.
Wow.
And then they tried to just build it internally, and they just like ripped our faces off. It was such a gut punch. It was brutal, but they always say that that's the way it's going to happen. And even when you're raising, they'll just discount whatever your biggest customer is. Imagine that they leave and they do the valuation, and usually they're right. And like in our cases, they were actually right.
Yeah. I guess, they've seen the story.
I've seen this movie 1,000 times. Yeah. Um, so then I guess Cody comes about. Now you kind of have PMF.
Yeah.
And I guess
Well, this was still Sourcegraph. Like
This was
still,
yeah, OG.
Cody was kind of like the AI coding assistant.
Yeah,
As like post ChatGPT.
yeah. So then tell me about, now you have Cody and then Ant, and
Yeah.
tell me like how those kind of came about. And
Yeah. So code search is still running. It's deployed to the Fortune 500. We also have what I would call like a Gen 1 AI coding assistant called Cody. That's based around the sort of like chat LLM application model. That's also deployed to a lot of enterprises in heavy use in a bunch of companies that you probably use or have heard of.
how many companies, just so we can get a ballpark of like scale?
Probably like net, we probably in the order of like hundreds. So like as a company, we're primarily geared towards serving like larger enterprise customers, at least for Sourcegraph and Cody. AMP is sort of a different story. But yeah, like a couple hundred of like the Fortune 500s and government agencies, everyone ranging from like growth stage startups, like Stripe or OpenAI, or to like public companies like Uber is still a customer, Lyft, a bunch of the big banks, and various government agencies around the world.
And explain like why, what did you expect to be really hard problem that you guys had to go solve, and what are like easy problems? Like, yeah, if I just do TF-IDF or something like that, like I'm done. I'm like, why do I need this? Why can't I build this in house?
Yeah, a lot of the hard challenges were really at the product layer and like conveying to people how to use a code search engine, because it doesn't really like a code search engine in the way that like it's commonly used. You're looking for regular expressions and like specific patterns that you want to locate in the code. It's very different from like a Google style search engine. So a lot of users have to understand like the distinction. There's also been a lot of like technical challenges that we've had to solve along the way around like scaling the type of index that we use for large code bases, making that work across like different branches and such. And then we also have this component that we call precise code intelligence, which is more like a compiler level understanding of the structure of the code, which, surprisingly, it's not the compiler part that's difficult, even though that's like the sexy part. It's really adapting that core to all the different build systems that you encounter
Interesting.
inside.
So how do you query that? Like, if it's at the compiler level, then was your question
Yeah,
the compiler level?
one of our first innovations, this is like going back to like 2014 or so, was we had kind of it was essentially like LSP before LSP existed. So if you're familiar with like the language server protocol, it's this like uniform layer where you like map from the specific AST nodes and types in a given language. So like you use the compiler to essentially like parse and type check the code, get all the types out, get the symbol table, and then you map it to this more or less like language agnostic schema, which you then can query from your application. So like the application layer, you don't have to have a bunch of language specific knowledge to complete an action like go to definition or find references, sort of like primitive code navigation actions.
Cool.
Yeah.
And then so I guess go to Cody and then AMP and
Yeah.
yeah.
Yeah. So Cody, so my background, prior to starting Sourcegraph and joining Palantir, I did some AI research at Stanford, but this was in like the pre-LLM days, right? You remember how it was, right? Computer vision didn't work. NLP didn't work. You spent like people did entire PhD theses, like engineering this one type of feature that worked on like a special class, like pedestrians walking or like cows in the field, and then
Log, sift, surf.
yeah, exactly,
Yeah.
exactly. Like people made their bones on like, hey, I figured out this one weird trick will make ML work for this very very specific domain. And so that almost like soured me on the domain a little bit, which is why when we first started Sourcegraph, I feel like we went through maybe like there was like a AI hype wave that I feel like crested maybe around like 2015 or so. I don't even remember that. But like chatbots were a big thing.
Yeah, I remember Andrew Ung's in 2012 when I first got there. The first quarter was like, I didn't believe in for 10 years. I didn't believe in AI, and then I started to see that there was this potential with like basically the support vector machine, like unsupervised learning KNNs and all this stuff.
Figure out the right kernel.
Yeah, like I think it like starts kernel methods like start to really work, stuff like that, and then it ended up not being any of that.
Yeah, yeah.
But
So like we didn't have any AI in the original version of Sourcegraph, despite like a lot of people coming to us and asking like, oh, you guys are saying code intelligence. Like a lot of VCs are like code intelligence. Tell me more about that. Is that like is it AI in it? And we'd be like, kind of, but not really. But then it was always like an area that I was kind of like passively following. And so when the Transformer paper was released, that was like interesting. And then you had like things like BERT, which were showing like pretty good results. And then even I'm blanking on the name now. What was it was like a very early NLP paper where they're just doing a basic text embeddings and showed that like
Glove.
yeah, exactly.
All visual searcher stuff.
Yeah. And like a lot of these, the parallels or like the applications to search are kind of like direct. So we were kind of like looking into it mostly as like an additional signal to incorporate into our search ranking. And then of course you had like GitHub Copilot too, and that like the autocomplete thing emerged as very interesting. And so those were kind of like the two vectors along which we were looking into like modern LLMs when ChatGPT was released. And then post ChatGPT, I think it quickly became apparent to us there was like um, a high degree of synergy between what that generation of models was capable of in terms of being able to synthesize things in the context window and do in context learning, and the ability to do retrieval over large corpi of data. So like the original idea behind Cody was, let's take the DNA we have around code search and combine that with frontier LLMs and build this coding assistant that's really good at generating code and answering technical questions in the context of these larger, messier code bases where just like the base model is not going to do as well. So that was Cody. We at the time we were a very like enterprise oriented company, and so Cody we kind of pushed straight to enterprise. And so it didn't really ride a lot of the hype wave of the kind of like 2023, 2024 era of AI. I think in hindsight, that was probably a mistake on our part. We didn't realize like the potential there. But Cody is still doing well. It's powering a bunch of automation and developers inside large enterprises.
And do you have like stats on Cody, like usage, like tokens emitted, or?
I don't think we index as much on like total tokens consumed, but like there are some pretty like interesting reported stats of like I never quite know how people come up with these metrics, but like everyone has some like pet developer productivity metric.
We bench,
Yeah, something like that. But like these are actually at customers, right? So like these would be tied to the ROI that they declare to their CFO in order to justify the cost of purchasing the software. And so like Cody's efficiency gains, they range between like 30 and I think like 60% efficiency gains in developer productivity.
So you're doubling software engineer throughput.
Yeah, and again, I mean, it's like at some level, every serious developer understands that like any sort of like developer productivity metric is not going to be a perfect proxy of what a software engineer does, but these are numbers reported by customers, and they're being used to justify the kind of like bottom line expenditures of what they're spending
Into dollars.
Yeah, exactly. Yeah.
0 points per labor hour, whatever it is.
Yeah.
Cool. And then I guess like your latest passion the last 5 months.
Yeah. So the latest thing is AMP, which was released in April of this year. And so it's kind of weird. It's like time has lost all meaning in some sense. Like it's crazy to think that AMP is only 5 months old. It feels like 5 years old. And it's crazy to reflect on the fact that like coding agents as like a product category weren't really a thing until like mid to late spring of this year. But like they've changed the way that I code, and they've changed the way that everyone I know codes.
Yeah.
I'm actually curious, like if it's changed things for people in this room, because like oftentimes I feel like I'm in a bubble inside of a bubble.
Yeah.
It's like we're like SF Silicon Valley is its own bubble, but like even within this bubble, I'll talk to someone at some other company and they're like, I don't really use coding agents much yet.
I mean, I think this entire lab is probably on all of them. I mean, raise your hand if you guys are using Cursor or using Claude Code or Codex. How many of you use all three? How many use two? At least two. Okay, that's most of the crowd.
And can I get a show of hands of like, if you were to lean one way or the other of like, hey, I still manually write most of the important code that I generate versus like the strong majority of the code that I generate is really like natural language out of me into an agent. Like who would say still like manually, like, okay, so good number, maybe more than half actually.
You guys are so old school. You guys are gonna be like deprecated
and then who here is like completely agent pilled, where it's like I don't even like writing for, okay, so basically no one actually.
Yeah, I mean we've all seen it do crazy things. Like Claude Code launched
Yeah.
was in a VM loop and just kept launching virtual environment after virtual environment after virtual environment. It was on his 5th one. I'm like, what are you doing? And so it's kind of the way I think about it is like, there's like, let's say one side of the spectrum, like normal folks, and it gets like Asperger's, like, and you get the, and it's all the way over there. It is like it's, you have to treat it like, it's like, well, you wanted me to launch a virtual environment. So I did, like, but one. Yeah. I was like, well, technically I did it. It was like, yeah. Like another example is,
And it's like, you're absolutely right. I shouldn't have done all that.
exactly, like, exactly. Yeah. But I gave it a task and then I say, don't stop until loss is going down. And so it did it. And then loss was going down, but it nanned out. And I said, no, it's giving nans, like fix the nans.
Yeah.
And it said fixed. And I was like, okay, that was fast, but let's see what happened. And I looked at the code. It had a check for is nan, and then it would replace it with the previous last 20 loss values.
That's like the equivalent of like mocking the success of your unit test, which it does a lot, right?
I think it is like, a little bit subservient. Like it didn't really want to do what I asked it to do. It's like, fine, I'll do the minimum amount that you need me to do.
Yeah. It's, reward hacking. Who among us is not?
But eventually I think we'll solve some of those issues, some of those like more ridiculous things.
Yeah.
But I guess like, how is AMP different from Cody, and like how are you thinking about it differently? How you think about those types of problems?
Yeah. So originally we were thinking about building a coding agent within Cody itself, but when we got into it, and this was like well before spring, like we got early previews of a lot of the frontier models, and so we're like playing around with these things. And originally we tried building it within the context of Cody, but I think what we realized is like I think we're actually in like the agentic era of LLMs is kind of like a distinct era from the chat era of LLMs. So like everything broadly gets lumped into like the Gen AI revolution. But if you think about the capabilities of the models, like we went from, tool use basically doesn't work except in like very special cases where you can record a slick demo video and push it out, to actually it works very robustly and you can use this like basically like all day, every day. In that inflection point, in my view, gave rise to a different AI application architecture, which we call agents now. Like all an agent is, stripped to its bare bones, it's basically like for loop plus a model and a set of tools that it can invoke to gather context or act on the world, right? And that is an application architecture that is very different than the application architecture that you had to use with chat LLMs, because chat LLMs were unable to, they lacked the agency to gather their own context. And so everyone was building what I call like fancy retrieval engines, or context engines that they would strap to a chat LLM, and then the super smart context engine would go and find the magical bits of context to place in the chat LLM's context window to generate like a single turn response. And like, I guess, the pejorative term for that is like GPT wrapper or something like that. But that was like the dominant architecture of 2023, 2024.
Because, and where does that fall down? Like why doesn't RAG kind of stuff work?
I mean, RAG would work fine for agents too. It's just, do you necessarily need as much complexity or smartness in your context engine now with agents? Because a lot of that intelligence has just been moved into the model, and you can give it a set of primitive tools, and the agentic search of like LLM plus grep is basically competitive or probably better in a lot of cases than like super smart, vector search.
Yeah.
And now it can do multiple iterated hops too, which is also very powerful. And so I think that shifts the application paradigm from like one that's very much oriented around like context fetching and these like one-shot interactions to much more just like bare bones text, like express your intent in text, have the agent do a bunch of things, communicate its progress, and then, react to it. And that's a very different application architecture. It's also a very different ideal user experience, I think. And so for those reasons, we're like, we should actually build this from the ground up rather than trying to bolt an agent into an application that was built for a previous generation of LLMs.
And so what does that mean, build it from the ground up? Like, how did you build AMP?
Literally from like 0 lines of code. With the first version was I didn't write the first lines of code, but it was basically like a for loop around Claude, free Sonnet, plus a set of tool descriptions.
Mhm. And how did you like solve these previous things that didn't work? And how much better did you measure the performance, like all that stuff?
Like what were our evals?
Yeah.
So we don't really have like evals, at least not in the like academic sense of the term. Like we have evals in the same sense that people have like unit tests or like regression tests. So like if there's like a workflow that we think is important, we'll have an example of that workflow, and then we'll run it whenever we make a major change to see if it breaks something. But like it was like in terms of the transition from like chat LLM to agentic LLM, it was such a big transition that um it was basically like a shift. So it wasn't like, hey, let's see how much better this performs on evals. It's more like it's obvious to anyone who uses this thing inside of like 5 minutes that it's capable of things that you could not even have dreamed of before with the chat-based LLMs. So let's just build for that new paradigm and do the thing you do when you use when you build a new product, which is like build it for yourself first and like use it like crazy. And it's sort of like your own internal like reinforcement learning process that guides you to what's going to improve things.
So tell me about like you've been doing this code search stuff for forever, for a
Mhm.
long time, maybe longer than anyone. And now these, cursors and, all these guys are coming out.
Yep.
And I'm sure there's a lot of pressure from investors, like, do things or whatever to change things. What did you like say, I'm going to, like, they're wrong for these reasons and we're not going to, follow the herd, and they're right for these reasons. So we are going to change some of the stuff we're doing.
Yeah, yeah. Like, to what extent do you listen to your investors as a startup founder? Is that the question? If you want, yeah, sure. Oh, look, I think we have some of the smartest investors in the valley. They've all like everyone on our board has been very successful, and they all offer like generally good advice. But I think like honestly, the most important thing as a startup founder is you always have to be rethinking things from first principles, and especially like the current first principles, not like yesterday's first principles, because things always change. And even the best investors, like they're not practitioners, right? Like they're not hands-on discovering what the new possibilities are directly like you are. That's not their job. That's your job. And so the advice that you'll always get from investors is really just like indexing on what they have seen in the past. And so there's like a lot of, X did Y and ended up with Z. So maybe you should think about doing something like X. There's a lot of like, hey, here's the standard playbook for things. And what we found is basically in like the past 3-4 years or so, like a lot of the standard playbooks have been completely inverted. Uh, like they're probably like actively harmful at this point.
Like what was a bad playbook?
So I'll give you one example, which is like, Sourcegraph, at the end of the day, we're a B2B SaaS company, right? Like we sell software to other companies to make their developers more productive. Um, it's a business to business sale, and there was a kind of like a way to do that. Um, between the years of let's say 2010 to 2022. Um, and I think a large function of that was like the technology landscape. It was changing, like there's never a year that goes by in technology where like big change doesn't happen, but it was not on the order of the change that we're seeing now. And I think one of the mistakes that we made was over indexing on the kind of like standard SaaS playbook when the AI revolution kind of like hit, when like ChatGPT landed and it became clear to like everyone that there was like so much potential in the technology. And so like with Cody, I would say like, we made a lot of we made a lot of right calls there. I think we were like the first like RAG code tool to market. But I think our like awareness in the public zeitgeist is probably far lower than the actual impact that we're having at all these large companies. But in large part because we pushed it through our kind of like standard enterprise B2B sales pipeline.
Like your strategic selling, predictable revenue, like
Yeah,
salespeople,
yeah, it's like,
get to your accounts.
let's go talk and listen to enterprise customers. They'll tell us, what they need. We'll take into account their feedback and build a product that they end up adopting.
Versus like the GitHub push to GitHub, get the
Yeah.
5,000 stars.
Exactly. And I think the fact of the matter is that in this environment, there's very few enterprise customers that actually know what they want. And much like maybe they think they know what they want like in 2 days, but in like 6 months, like where will the landscape be? Like they don't know. I mean, even we don't know, right? Because things are changing so rapidly. And so I think what we're doing now is we're kind of embracing that with AMP. It's like we're almost running AMP as like a separate entity. It's almost like a research lab. I mean, not like this one. We're in a real research lab right now, and we're not like we have published 1 or 2 papers actually, and I think we'll publish more. But we're not in the business of publishing papers. We're still in the business of building a product that people buy and use. But the way we're running it is in the spirit of like, let's go figure out what the future looks like and invent it. And so it's like a really small core team, probably around like 10 people right now. And we build it in kind of this crazy way. It's like we're essentially trying to build it in the way that we think everyone should be building software in like, 1 to 5 years, which is like cut through all the process. Like the old way of building software is that like you had many hands. Like software development works in cycles, right? Like you have the software development life cycle, SDLC. If you ever start a dev tools company that sells to enterprises, you'll hear the acronym SDLC many times over. And that's a standard loop. It's like one product iteration cycle, right? Like you go from idea to code to feature to deployed, and now you're observing all the errors and stuff. And the old way of building software is that there were many hands that would touch the product or feature at every step along the way. It took many hands to complete one step of this loop. And I think the world we're going towards is it will like one single human will be able to drive many iterations of this loop in parallel. And so that's very different. So like one concrete thing we do, which like strikes people as kind of like nuts at first, is we don't do code review. Like everyone on the core team has push access to main, and the default, unless you really need or want someone to like give their expertise on a change, is like own the change that you're making, push it, and if it breaks, it's your fault. Like none of this like blameless post-mortem. No, it's like you break things, it's on you to fix it.
Your name's on the Git commit.
Yeah,
and you pushed.
And if you think about it, it's like a lot of the things that are kind of like standard best practice in software engineering, like blame the process, not the person, right? It's something you hear again and again.
Doing the opposite.
Yeah, and it's almost like, yes, that was it was almost out of necessity before, right? Because there were so many hands that touched it, like you couldn't point the finger at like a single person in the process, just because it took so many different roles to bring a feature through to completion. Meanwhile, like, sometimes I talk to like people working other roles who are like aren't engineers, and they're like, wait a minute, like you're telling me if you push something that like takes down the site and costs the company millions of dollars, it's not your fault, and you get paid how much? So like I think it's like, like these best practices, they've existed for a long time out of necessity, and they're not bad best practices for the way things were, but like a side effect of having these best practices was that you had like such a diffusion of responsibility in the whole process of creating software. And I think that diffusion of responsibility resulted in a ton of inefficiency. I mean, it's like, I don't think it's controversial to say that like large engineering organizations are extremely, extremely, extremely inefficient.
Yeah, I mean, it's largely because let's say I'm running Walmart.com or running the perpetual inventory system, whatever, like you want 100 eyes on something.
Yeah.
Because if I push a bug and the system goes down, I lose millions and millions, hundreds of millions of dollars.
Yeah.
And so it's like, slow, bureaucratic, you want to make sure that you have massive QA and test, slow shadow deployments, like
Yeah.
all that stuff. Like,
Yeah.
okay, is everyone good? Okay, we've done every single thing. Okay, push.
Yeah.
And then it still goes down CrowdStrike for details, right? Because the configs on some server somewhere.
Well, that's the thing. Like a lot of the process is in some sense necessary, but then it ends up being kabuki as well.
Yeah.
It's like, does it actually? Well, like, let me ask you this: like, does code review? Like, what percentage of the time do you think people actually do a thorough code review?
It's all, looking over like, oh, well, you should comment this better. And it's like, you didn't even look at the core
Yeah.
logic.
It's like, I'll tell you when people do a thorough code review, when the change is like 10 lines long.
Yeah.
Then they'll do like a very thorough, like surgeon's glove, like I will nitpick every single detail.
Yeah.
But like any change that's like 1,000 lines or more, it's like, man, I got my own deadlines
Yeah.
to meet.
That's true.
And me being done with this task is literally just like a looks good to me away.
And we've done different models at Focal too, where we had like pair kind of thing where like it wasn't like an engineering manager that's doing the code review. It would be like peer, like just find someone else to do it. So who do you grab? Your best buddy, and your best buddy is not gonna like really. It's like, okay, fine, yeah. You approve mine, I'll approve yours. It's all good.
At Twitter, when we were working with them, the head of engineering wrote this script. It was a script to detect code review cliques.
Yeah,
Like clicks in the
in the graph.
in the code review graphs, because what they were finding is that like these junior engineers would all get together and review each other's code, and that would pass the bar. But
Someone you wouldn't actually same on papers, like how many self citations and all that kind of stuff. Like, oh, all of like Professor One, everyone in the lab has to cite that lab.
Yeah,
all the papers.
yeah.
So I actually interested the most interesting question I think I want to ask you about is like meta, like upclick a little bit.
Okay.
There is the scale pilled, the Dorkeshes of the world that really think the only thing we need is more tokens, bro. Like that's like all we need.
Yeah,
and we're gonna get there.
Way more tokens.
Just more tokens. And like you guys have all the tokens. Like you guys have all of the enterprise grade tokens across hundreds of Fortune 500 code bases. Each code base is like, can't fit on like a terabyte hard drive. And like,
yeah,
why isn't it true? Why are they wrong? Why hasn't it happened yet?
Well, okay, so I mean, there's two sides to your question. One is like, what's the value of enterprise tokens, and the other side is like, is more scale all you need? So the shorter answer is the first question, which is like enterprise tokens are great, but the issue with enterprise tokens is that you can't really use them for training a general model that gets used outside the enterprise. Like most enterprises are very privacy and data sensitive. And so you're not allowed to roll those tokens in.
But if you could, do you think it would solve it? Like,
no, I don't think so. And here's why not. So I think, I mean, I will get very hand wavy and, allow me to opine why I don't think that like pure scaling is going to lead us to like AGI nirvana. I view the current, LLM architecture and all the variants thereof. What they are is they are like universal pattern matchers or curve fitters, right? Which is in some sense like amazing. It's like if there exists a distribution from which like you're sampling data, what this means is like you just have to sample enough data, throw this curve fitter at it, and now you have a machine that will kind of like predict that distribution. So like anything you can represent in whatever modalities that this model consumes, like text or image or whatnot, like you can now train a function that goes from like X to Y, where X is the input and Y is the output. Yeah, there we go.
Which Dan didn't like, by the way. He thought it should be Y down here and X out there. And I'm like, oh, really? Okay. Interesting. Like, not gonna.
Y is always the output.
Apparently, that's why we learned it.
So like maybe in like France or something.
I don't know. Dan has his own reasons. They don't know why he was saying that. I don't know. Anyway.
They used to have O's too.
Yeah.
For observations.
True, yeah.
And then H was the hidden layer. At least
like early Schmidt-Huber papers. I think this is it. I think this is the LSTM or RNN setup.
So it's like a universal pattern matcher, which is really powerful, but it still means that you have to collect the data that represents the distribution that you're trying to fit. And so the question is how to get that data. And so like you have certain knowledge domains, which like there's just an enormous abundance of data, like textbooks, like the written word, code, images, like these kind of like raw, low level, kind of like elementary data processing and structuring tasks are all very like there's tons of data out there in the public domain or just like available, right? And it's cheap to generate because like you don't the labor required to generate this data if it isn't available it's not gonna, I mean, it might cost a lot of money because it's still human labor, but it's not like it's not intractably large. Um but then you get into like once you conquer those kind of like primitive tasks, then it's like, okay, what's left at the frontier? And I think what's going to be left at the frontier are um, maybe like two categories of things. Like one is going to be sets of tasks where it's like at the frontier of human knowledge. So like you're making new discoveries, and these discoveries are undiscovered for a reason because they weren't, discoverable through just like simple combinatorics of like existing knowledge. And then the second category of things is like anything that's adversarial, right? Like anytime where it's like you with AI versus another human with AI, there's gonna be like novel strategies, and you're like both competing over like a scarce resource, or it's like a zero sum thing. Then then like the frontier is always shifting, right? Um, and so if we think about the things that I would describe as AGI, like AGI to me is like, first truly human level AI, maybe like godlike AI. Which is not to say like existing models can't be superhuman at some things, right? Like they clearly are. Just as
Not like globally dominating on like
yeah,
a set of all things humans can do. There's not one element in the set that AI that the humans can still do better.
yeah,
But
exactly. And for that, like what data sets exist for that sort of thing, right? And so like then the question is like, well, how do you generate the data to do that? And so like the way I think about it is like the frontier is gonna be pushed by this sort of like alternating ascent. Actually, do people still learn about expectation maximization? Is that a thing? EM? No? No.
that's
Oh, that used to be like one of the pillars of like
and all the proofs of convergence for EM.
yeah, I guess it.
2 steps.
Yeah. So like EM was this I mean it's a classic algorithm that basically the insight for EM is you throw it at domains where like there's some sort of hidden data. The details don't really matter. The basic point is that like EM there's like two alternating steps. One is you take your existing model and you generate some data with it. And then you take the data and then you train a new model that better fits that data. And then you sort of it's like this alternating staircase of like first you generate the expected data given the existing model parameters, and then you find maximal likelihood maximizing model parameters to fit the data. And somehow this works. It like leads to this thing that gets better and better.
Yeah. With light assumptions, it converges to like the global
Yeah.
maximum and all that stuff.
And so the way I think about like product development or like frontier advancement, in the age of AI is like the frontier is really going to be pushed by this alternation between taking the current frontier models, building an application scaffold around them that accomplishes some tasks that couldn't be done before. So it's like, before you had to handwrite all your code. Now with LLMs, maybe not in research domains, but at least in like, producing web applications, right? Problems like more or less solved for like simple web apps. You don't have to write, you don't have to handwrite React code anymore. So like now you build an app scaffold to like produce your web app with minimal human line smithing of code. Now you have a new kind of application which still requires human direction. And in the process of using that application to generate these applications, guess what? You generate data. You generate tokens showing mapping from like human inputs, which is what the human's typing in, to like the ultimate output, which is the application that gets out on the other end. And now you have this new data set, right? Which now like it's a distribution that did not exist in the world before. This mapping from like human natural language to complete application, right?
Yeah, and in my mind, like this is generator verifier gap kind of like it's cheap to check the answer to Sudoku, but it's hard to generate the answer.
Yep.
It's cheap to check that the code passes the unit test. It's hard to generate the code that passes the unit test. But I guess that argument is map reducible to scaling is all you need, because if I just keep doing if I have code, for example, and I have a bunch of unit tests, like all I need is more unit tests. And then I can generate all the programs that satisfy that unit test and train on the more tokens. And then I get there. Yeah.
I guess in some sense, but it's like it continues, right? It's like every time so it's like you take your frontier models, you build the new like AI apps, right? Now with the apps, they generate data. You can feed that back into a new generation of models. Now you have a model that can map. So like now you no longer need the old app scaffolding. Now you build a new app scaffolding around like Gen 2 of the models. And that's the step by which. So it's like it's not like just by like talking more or consuming more. Like you still have to generate the tokens, right?
Yeah.
Yeah, I guess that's my point.
And I guess like to me, and there's probably people in this room that would know this better than me, but like what makes it not work is the conditioning on it satisfying the unit test. It makes it not the same distribution. Now it's conditional distribution,
Right.
And training on that conditional distribution like isn't just dogfooding the same tokens and distilling on myself.
Yeah.
You know, like I need some test that will condition.
Yeah.
But
I guess maybe the question you're asking is even more fundamental, because like what I'm saying is that like you could just run this like alternating like app then model ad infinitum, and in theory like any sort of knowledge work will be automatable.
I'm pretty sure this is what OpenAI is doing, and Noam Brown has been talking about.
Yeah.
This as long as we can leverage gen verifier gap.
Yeah.
It's easy to verify, hard to generate.
Yeah.
And just keep throwing more tokens, and like I can sample it. Essentially, ends up being guided search, because the search is over the trajectories that pass the unit test.
Yeah.
And conditioned upon all then I train and get better on, more likely to output the things that pass the unit test.
Yeah.
And so I'm shifting the distribution towards things that pass unit tests.
Yeah.
And I get better and better at that.
But I think you would say that there's like a fundamentally different type of intelligence.
Yeah.
Where it's like,
I think that like, it's still the structure, the Robbins-Monroe structure that we have with backpropagation, et cetera. Like this task is called meta learning, where by level optimization, I have one procedure that is getting better at solving other procedures.
Yep.
And what actually happens in backprop is the opposite. If you train on task 1 and you have a completely orthogonal task 2, and I take that same theta, it will do worse than if I started from tabula rasa.
Yeah.
And so if there is nothing overlapping from task 1 and task 2, that's 100% true.
Yeah.
And so backprop loses plasticity, and this was the Sutton paper, loses plasticity as I train more and more and more tasks. It's the opposite of what you want. You want something that will increase in plasticity as you add more and more tasks, and figures out this sort of thing. And like continue backprop, the trick is just literally taking neurons that don't fire that often and re-Xaviering them.
Yeah.
And then it ends up getting there. But I still don't think that's enough, because it's this distribution issue. If you're targeting to one distribution and then you train on a completely different distribution and you keep doing that, you've lost so much plasticity. It is not going to work. And so that's one argument. And the last argument I have is, well, I'll stop there.
I would say like it sounds like you're after a form of intelligence that like will never overfit.
Yeah, it's
Sometimes,
exactly.
right?
And like,
Whereas like all LMs do today is overfit like crazy, and like it turns out like if you can generate enough tokens, it's fine to overfit.
Yeah, exactly. I mean, the example I always give is if I
not for AGI, but just for like what I want to do, which is automate knowledge work.
Like I worked in self-driving car. If you take 100 million hours of self-driving car data from the United States, and I have an amazing model, and I deploy that same policy into Australia, and I take a human on the same exact situation, which one is going to do better? Like the LLM will do it, or the model will do horribly, and probably will need another 100 million miles. To like not.
First time you see a kangaroo is gonna be like.
I mean, no, it's the opposite side of the road. I'm driving on the wrong side of the road.
Right,
I mean, like this thing is gonna kill everyone. I mean, it's gonna just take U-turns and like just I don't know, kill people. But so we are super flexible in the policies that we've learned, and it doesn't take that much for us to have a massive shift in policy. So the example I always give is like, when I was 16, I got in a huge car accident. I made a left turn, and I got T-boned by a car going to hockey practice like 5 a.m. And so the update to Francois' policy was, don't get in cars. the update to, if I did PPO or Turpo or Grupo or whatever, I would gradient clip out, and it would say, if I had enough of these examples, at 5 a.m. at that one intersection on Tuesday, the 15th October, don't turn left.
Yeah.
If that neighboring car coming to me is red.
Yeah.
Like, no, like the application has to be on a much more general domain.
Yeah.
And that's what we don't do that. And so the PPO gradient clips out all the signal because I'm in this trust region. I can't move too far out of it. Otherwise I'm unstable.
Yeah.
And so all the star PO methods I'm just super out against. And that's the core thing that gets these things to work. RLHF is all using Grupo, Turpo, PPO, DPO, etc. And I just think it's fundamentally wrong. It just doesn't mentally map to what happens with us.
Yeah.
Where I'm like, I was afraid to get in cars, like literally for like a year.
Yeah.
So anyway.
Yeah, no, I mean, that makes a lot of sense. And it definitely serves my ego as a human. There's still something that separates us. But like, yeah, I agree. I think it's like, from where I sit, it's like, I'm not doing fundamental research. And so it's almost like I don't even think about, like, AGI to me it's like a hype term.
You got to raise your Series F.
Yeah, exactly. Well, all we're doing is like we're finding interesting, valuable distributions, like economically valuable data distributions against which we can fit this universal pattern fitter, and then they will emit tokens that replicate that that can be adapted to minor perturbations in what the inputs are, well enough to quote unquote generalize to an existing workflow that we can automate, like creating a simple web application.
I'll do one more question, and we'll hand it to you guys. So how do you think about, over the next 1 to 5 years, who's friend, who's enemy in this? Like, you have Cursor, you have your Replets, you have your, Codex, you have your Claudes. Like, who are you going to work Inception? Who are you going to work with? Who do you not? And like, how does it all kind of work in your head?
Yeah. It's funny because like right now in AI, like things are changing so rapidly that like if you squint, like everyone seems like a potential competitor. Like everyone's chasing like greater intelligence, and a big factor of that is improving a model's ability to generate code with feedback. And if that were the case, that it's like literally like you couldn't walk down the street in San Francisco without running into a potential competitor. And I think that's just the nature of, like, it's an indication of how early we are in sort of understanding the implications of this technology and how things play out. But in terms of like how I think about evolving our company, I don't really view it through a competitive lens. I think the way I think about it is like the knowledge domain that we care about is really the domain of creating software that works at scale. So like creating the software that powers the digital infrastructure of the world. That's what we want to solve at Sourcegraph. And so what should the process of creating that software look like in the future? And I think, like, thinking about it in that way, I don't really see too many other people like thinking holistically in that sense. Both in terms of like the technical approach and the kind of like end goal of where we're trying to land. So like I'll start with like the technical side of things. I think like we're doing a couple things like differently with AMP that I don't see anyone else really doing, which is like we're multi-model by design in the architecture of AMP, but not in this kind of like model selector, mix and match whatever model with the scaffold type of way. Because if you think about it, like all what we're building is it, like what we call an agent versus like a tool. They're both just functions. And so we're just constructing functions that take an input and yield some sort of output. And then we have this application architecture that is able to compose functions to do interesting things. It's like, call them sub-agents or whatnot if you want to raise a VC round. But what we're thinking about is just like what should the design of these functions look like? It's not like a property of the model. It's like you look on Twitter or whatever like the popular discourse is, and people are like, oh, I tried out GPT-5 and it has this quirk, or I tried out like Kimi K2 and it has this quirk. And it's like, well, it's not really the model. It's really the embodiment of the model within this application, this agent scaffolding. And that's what you're reacting to. And I can make it do very different things if I tweak the system prompt just a little bit. So like we're really thinking of it as like the agent is sort of like the fundamental building block rather than the model. And then the other thing that we're doing very differently is and this is really like the lessons that we learned over the past like 3 years or so. We're not trying to prematurely scale. So like we're not like AMP is being adopted by some of our enterprise customers, but we're kind of like pushing it through those pipelines because the last thing we want to do is bend over backward to solve a bunch of like enterprise kind of compliant checkbox requirements
That'll slow you down.
when the landscape is not settled. Like we think it's very, very early in terms of how this is going to play out. And then that ties into like how we think about like how the product landscape is going to evolve. It's like if you look at the AI dev tool landscape today, everyone is kind of like slotting in their point solution at specific places in the existing SDLC. It's like the existing SDLC has a place for code review. So like there's a bunch of code review bots, for instance. We actually think like the whole loop has to be kind of like rethought in a sense, where it's like the nature of the loop is changed. It's no longer many hands driving one loop. It's now like one set of hands driving many iterations of the loop, to the point where like you're not even going to do code review. Like why do code review in GitHub PRs anymore? Right. So it's like it was not a great interface to begin with.
Right.
And now with like coding agents, like I spend probably like 80% of my development time like effectively doing code review,
Right.
like reading through agent output and understanding what it's doing and making sure that it's not doing something dumb, like subtly wrong. And that's effectively code review, but I do it within my editor like many times over.
Right.
And on an actually like thorough basis, because if you don't, you're just going to spaghettify your code. So like we're trying to like think through like how the whole process should be rethought from the ground up.
Interesting. I have more, but I didn't want to give it to these guys. I think Owen had a question. Do you want to?
So the question was like, there's been a handful of like foundation model labs that have demonstrated the ability to like push the frontier in research, and they're showing like results in all these domains, like pushing the frontiers in biology and coding and whatnot. What does it look like to build a company in that sort of future? Or maybe like the kind of undertone here is like, does it make sense to even build a company outside of these major model research labs at this point? Yeah, so the way I think about it, I actually have maybe like a spicy take on this. Like I think like in the future, if you're building software that's for like a purpose, like boosting productivity or something, I think you will have to bake into your DNA both I think the two core skill sets of building in the future are going to map to those like two steps of like the iterated ladder that I mentioned. Like one is you're gonna have to figure out how to like train models effectively. And then you're also gonna have to figure out how to build applications effectively that allow you to generate the tokens that you'll need to train the next generation of models. And the question I would ask you is, number one, will that skill set be limited to like a handful, like less than a dozen companies, or is that going to expand to like every company in the world is gonna view that as like a core piece of like internal DNA? I suspect it's more the latter, just because of labs like this one, where like research is the open collaborative spirit of research and sharing these learnings. There's no like hidden secret that any of the proprietary model labs hold that I think is really driving their changes. It's all just like a mix of like experimenting with the same basic knowledge that everyone more or less shares. The second thing is, I think in the US there is a almost like unique aura around foundation model labs that I don't think exists, for instance, in the Chinese ecosystem. And it's kind of curious if you think about it, because if you think about the money raised in terms of venture capital by AI companies, like the vast majority of it has gone into model layer companies. And like the question is like, why is that? Oh, one is because like models are expensive to train, but two, I think, is like the original narrative that we all were sold in like late 2022, 2023 is that like AGI is coming, right? Once AGI arrives, the game is up. Like why do anything?
Right.
And if you're a true believer in AGI, then like, yeah, there is no point in building a domain specific application or agent anymore. The funny thing is now all the foundation model research labs are getting into the product game.
Mhm.
Like everyone is trying to verticalize. And then the question is, if you're a true believer in AGI, why would you ever invest in an end user application? If you're the only lab that's going to have AGI, then just let others build on top of you, and you will hold all the cards because you have the differentiating model. And I think, like, you compare that to the Chinese ecosystem, which, like, I don't think any of the major Chinese players viewed themselves as model labs, from the get-go, either out of, like, necessity or through some, strategic vision. They all viewed models as, a means to building a compelling end user application experience, hence the vibrant open weight model ecosystem in China, which, quite frankly, is, like, it's outperforming the American open weight model ecosystem. And so in some sense, it's like, uh, I think the consensus has been in the past like 2 years, it's like the model layer is extremely important, and there's some secret sauce there that is not going to get like competed or commoditized away. I think in the next 2 years, it's gonna be really interesting to see how the interplay of like proprietary models versus open weight models plays out, because we could very well be in a world like in a very short while, like 6 months, 12 months from now, where the vast majority of application agent builders are building on top of open weight models.
Yeah. And the more meta like answer to this I would give is like it's always going to be true that a company will disrupt the incumbents and like take everyone in 2020 thought that Google was going to be have a monopoly in AI. Not even like they were going to be, they're not even leading. Like I still don't use Gemini, to be honest. And so like, what are they leading in? I'm not really sure, but like, and it's just been 4 years. And so like, and the reality that why is that? Because Sundar had regulators, they were monopoly. They lost a monopoly lawsuit in Europe. They lost a monopoly lawsuit here, like everywhere. And so he doesn't want to anymore. Like, I think behind closed doors, if you get Sundar drunk, I think he's actually like, I love ChatGPT. I love OpenAI. Please take market share away from us. Like, just take the regulators away, the ease up off me. And like, that's the reality. So like, that's antithetical to innovation and, so that left the door open to a lot of things. And I'm going to say the same thing is going to happen to, OpenAI if it's not already, because there's already things that they're not going to do because they have so much product momentum in one direction. Jared Freeman used to tell me in YC, like, don't worry about your competition or who you even consider to be competition. Don't even worry about it. Here's a good test. Go and take your entire product roadmap and PDF it and email it to your biggest competitor. I bet it won't change one thing that they do. And it's true. And it's
Yeah.
like, because, and you felt this, like why you needed AMP to be a complete restart on a new repo
Yep.
to like from the ground up, because you have your customers and they're promising you money. If you build it, we will come.
Yep.
And they're like, well, that leads you down this path that is short-term gain, long-term loss.
Yep.
And like, we might miss the whole market, but we made, Salesforce happy.
Yeah.
And so like, and that's the way it kind of happens. And that leaves the door open to big misses, like penny wise, pound foolish kind of decisions that happen in all major companies. And so any company that's above 100 million in revenue is already suffering those issues. And it never, and it's just like Jeff Bezos says, what's not going to change?
Yeah.
That's not going to change.
Yeah, well, once you have like an organization that's greater than 100 people and like an enterprise sales team and customers paying you a lot of money, you're on a treadmill
Yeah.
where you're optimizing. Like, you're going to do what every other business does, which is listen to your customers and respond to their requests. And look, that's a great way to run a business, right? Like, it's if you're running a business, it's good to listen to your customers and kind of like do more or less what they tell you, with some adjustments. But I think the fact of the matter is that it's like things are changing so quickly right now that like remaining small and nimble is a huge advantage.
And it's really hard. It is because you have politics. Everyone is trying to like, get, you know, like get you to go in one direction, specifically your customers. And if they're high paying customers, if that's 10% of revenue or more,
Yep.
that is the biggest board of directors you'll ever have. And they will steer you to do things you really don't want to do.
Yep. Yep.
And so, yeah. What else? So I'll throw out one is, you similarly with Focal, we would sell into retail, and retail workers would have to use this, and the pitch was on productivity. We're going to make your workers much more productive. And the simple thing that people would say back is, well, if you're making my stalkers twice as efficient, then I need half the stalkers. And it's like, yeah, but you have 20% out of stocks. So why don't you like go and, invest in sales? And that's what they typically do. But there is a optics that that we are automating and firing people, which is like what everyone always thinks when they think about automation.
Yeah.
Similarly, if my software engineers are 60% more productive, I need half the engineers. And why is that completely wrong?
I mean, I think it is completely wrong. And the reason why it's wrong is like, okay, it's great. You can now accomplish the same thing with half the engineers, but guess what? So can your competitor. And so as long as you're not a monopoly, you're competing against someone and software quality matters. I mean, either it matters or it doesn't matter. Like if you're truly in a space where it doesn't matter past the point, then like all you do is like fix simple bugs. And once those are all fixed, then fine. Then like, yeah, if maybe you don't need, all the devs that you have right now. But I think for the vast majority of people building software, it's not just about like checking the box. It's about building a superior product experience. And as long as there's this like adversarial relationship where like your customer has a choice of going with you or your competitor, it's going to be a matter of like who can build the best software quickly. And I think what we're going to find is, we're going to look back on the pre like 2023 software as like, man, like software was really bad back in the day, like how did we tolerate like so many pieces of software that just like have horrible user experiences? Like think about like all the software that you use in your day to day and all the like pitfalls and like poor UX that you have to deal with. I think that is just going to get
Pre-C, pre-C++, like
yeah.
you had to deal with all these, like you have to write assembly.
Yeah, exactly. All of the like pointing and clicking through like various like nested menus and whatnot. I think we're just going to have much more streamlined software experiences. And I honestly think there should be like way more software engineers in the world because I think the demand for quality software tackling like different knowledge domains is almost like limitless.
Yeah. Do you think that, like, back to your SDLC, like who is the person who's running that? Is it just the PMs and it's not even the engineers? Like,
So my take on it is like the roles as we know it are going to go away. Like product management as the role that exists today inside large companies is going to go away, and so will your classic like front end engineer. Like your application level engineer is going to have to think at the product level in order to be effective, or like the best ones are going to do that. So like the way I think about it is less so like is it us devs that are going to get eliminated or the PMs that get eliminated. It's more like whoever can think at the product level and deliver features end to end that solve real user pains. Those are going to be the people that like drive progress forward, and therefore will be the beneficiaries.
I completely agree. Like you need like the Google TPM, for example.
Yeah.
You need like a technical product manager. I understand the code. I know what the code can do, what's technically possible, but I also understand my users and how to make a great product. Like I completely agree with that. All right. Any last ones? Last chance? Everyone thank Beyang for coming and for having me. Yeah. That's our first one.
Thank you so much. Yeah, I appreciate it. Yeah. All right. Thanks.